In this video, we're going to go through the anchor bolt calculation included in your TEDS trial. Note that this module only includes a design for the anchor bolts themselves, along with the Appendix D checks, and will require you to input the load per bolt row. We do offer a calculation that also includes the base plate design along with the anchorage. In this module, you can design the base plate along with the anchor bolts by simply inputting an axial force and moment at the base of your column. This is reviewed in a separate video. To begin any of our TEDS calculations, simply click on the New button and navigate to the module you would like to run. Once you have located the module, you can easily just double-click on it or select the Calculate button in the lower right-hand corner to begin the calculation. Don't forget to check out the notes we've included for each calculation outlining the scope, which codes were used to create the calculation, and any assumptions and limitations that have been made or are present. Once you start the calculation, your output page will start in the background, and then you will be presented with a series of interfaces. Each one of these interfaces works like a book, top to bottom and left to right. You will also notice a parametric sketch on the left-hand side that will continue to update as you move through the calculation. So starting with the geometry, simply enter in the bolt group pattern you would like to check. In this example, we will look at a standard 3x3 configuration. You can change the spacing by using the arrows to the right or by simply typing in the input box. Next, we will move on to the foundation details. We can select whether the concrete is cast against earth, exposed to weather, or neither of these scenarios. We will assume we are working with a 4 foot by 4 foot spread footing that is 2 feet thick and cast against earth. Notice that you can simply type in any unit into the input field and it will automatically be converted to the specific unit being required in the calculation. This can be very handy if you need to switch back and forth between metric and imperial. Now on to the anchor bolt details. First, you can select from a variety of cast-in-place options like headed end, hooked end, and headed stud, but don't miss the fact that you can also select proprietary bolts. If this option is selected, you can then go into the bolt details, select which type of post-installed anchorage you would like to use, then enter in all of the variables associated with this bolt. These come from the ICC reports and should be published by any bolt manufacturer. For this example though, we are going to stick with the headed end bolt. For all cast-in-place bolts, you have the option for using either torqued or untorqued bolts. Once in the anchor bolt details, we will first try a bolt diameter of 1 1/8 inch without adjusting the number of threads per inch, and we'll leave the bearing area of the head to be 1 inch squared. We'll increase the embed depth to 9 inches and increase the base plate edge distance to be 2 inches. Obviously, each one of these may change based on your specific scenario or condition. You will notice that our sketch is updated with all of the information we just input. You can pan around and zoom in and out of the sketch using the scroll wheel on the mouse. Moving along to materials, we will accept the default values for most of these, but will change the supplementary reinforcement factor to 1.2, since we will likely be using a number 4 bar or greater in the footing between the anchor and the edge. If you are unsure of what any of these factors are, or don't have access to the code that outlines them, you can simply hover over the information bubble to be shown the code excerpt. Now on to forces. As mentioned at the beginning of this video, because we are using just the anchor bolt calculation, the loads will need to be added per bolt row. This is helpful if you are checking things like equipment anchorage or tie downs for certain elements within the building that may not include a base plate. Notice if no axial force is applied and only shear force is considered, you will still need to specify how many rows of bolts will be used for calculating the concrete pry-out. It will default to 1 row to be conservative, but can be changed to include all rows per your engineering judgment. In this example, we will assume all 3 rows are taking an axial load and will add a corresponding shear force. Unlike many other software tools that will assume just the last row of bolts will be taking your shear, TEDS allows you to use your engineering judgment and select the number of bolts you would like to be included in this calculation. Next is seismic. If you want the seismic checks to be included in your output, simply click on the box to include it. Even if you are in a seismic design category that doesn't require any additional checks, by selecting this box, a note will be added in your calculation stating this fact. However, if you are in a category that does require additional checks, you will need to select the appropriate seismic requirement of ductile yielding, non-yielding, or increased design load. Notes will be provided explaining what needs to be considered for each of these requirements. For this example, this option will be left off. Now there is enough information to view the results. Notice the summary of each Appendix D check listed. You can also toggle between the different sketches of the shear breakout, tensile breakout, and side shear breakout. This calculation will default to using the ACI 31811 as it is the most current adopted design code. However, you can change this to an older code through the Options menu. Lastly, you need to select your output options. Here you have the ability to change the title of your calculation to something more meaningful for your project. You also have the option to select a full output or a summary of this calculation. Depending on your region and who will ultimately be reviewing these calcs, this may vary. However, it is very simple to switch back and forth as needed. You can also select which graphics you'd like to include within the output. Once you select Finish, assuming you selected the full output, you will get a line-by-line output going through each of the calculations included in the design. Every variable will be defined, each equation written out, and every code reference provided. This eliminates the black box feel entirely. Even if a certain check is not required based on meeting a specific requirement within the code, TEDS will outline that requirement and where it came from to justify not needing to show the check. Now, if something needs to be changed within the calculation, simply click on the Calculate button and the same series of interfaces will appear. Make whatever changes are necessary to update your calculation and hit Finish. The output will automatically be updated. Be sure to check out the other TEDS trial videos that go through each of the other included calculations, as well as how to customize them using TEDS for Word.